One thing I learned from teaching last year was a lot of my students don't like fractions for whatever reason. I think they're great. So let's learn a bit more about them and make them a bit easier for you. So we want to write this expression, right, which is a sum. So we're adding two fractions. We want to combine it as a single fraction and put it in its simplest form. So a technique a lot of students know how to use is cross multiply. So let's start there and see some of the problems we run into if you just use it as you know it. But I'll show you how we can still answer it correctly. And then I'll show you one other method which might be a bit easier for you. Alright, so first up, let's try the cross multiply method. So that's where we multiply the numerators of each fraction by the denominator of the other fraction, and our new denominator will be the product of the two denominators. So what this looks like will be 9 times 2x plus 6, and to that we will add 3 times x squared minus 9, and that will be all over the product of the denominators. So x squared minus 9 all times 2x plus 6. Okay, so we've technically combined it into a single fraction, but we haven't put it in its simplest form. So to do that from here, let's go expand and see where we end up. So in the numerator, we get 18x plus 54, then plus 3x squared minus 27. That's all over 2x cubed plus 6x squared minus 18x minus 54. Great. So in the numerator, I see we have a 54 and a minus 27. And I'm just going to write it in standard form. So that's where you put the highest power term on the left, and then you go in descending. So the 3x squared is the highest power, and then plus 18x, and then 54 minus 27 is plus 27. And that's all over 2x cubed plus 6x squared minus 18x minus 54. So that denominator doesn't change. Okay, it's looking a bit simpler, maybe. So you'll get to here and you'll be like, okay, what do? I have a cubic in the denominator. So whenever you have a polynomial, so like a quadratic or a cubic in a fraction, a really good approach is to factorize it and then look for like factors that can cancel. So I notice, before we even get to that, in the numerator, I can pull out a common factor of 3, just to simplify it a bit. Right, because all of those terms are a multiple of 3, and in the denominator, everything's a multiple of 2. Right, so that simplified it a bit. But now we can factorize the quadratic and the cubic. But to save us some time, we can do that on our calculator. Actually, the numerator is pretty easy. So what multiplies to positive 9 and adds to positive 6? Right, x plus 3 and x plus 3. So 3 times 3 is positive 9, 3 plus 3 is positive 6. That wasn't too bad, but the denominator is a cubic. So to solve or to factorize that, we go menu, equa for equation, polynomial F2, degree 3 for a cubic, and see we have a, b, c, d. So in this problem, that would be 1 for a in front of the x cubed, 3 for b, negative 9 for c, and negative 27 for d. And we can hit F1 to solve. And this is saying there are solutions at x equals 3 and there are two solutions at x equals -3. All right, but so that's the solution. To put it in its factorized form, we actually do the negative of those. So that there's two factors that are x plus 3, and there's one factor at x minus 3. So two factors at x plus 3, and one factor at x minus 3. So again, all as we did is we factorized the cubic. And to save us some time, we did it by solving it like equal to 0 on our calculator, and then flipping the signs to put it back into factorized form. And so we're here, and we see all these factors cancel out, and we're left with 3 over 2 times x minus 3. And that would be our simplified fraction. So that's one method. Let's try another. Have a break if you need, grab some water. All right. So going back to the cross-multiply method, instead of cross-multiplying completely, we could think about common factors that exist already. So if we do 9 over x squared minus 9, so x squared minus 9 is the same as x squared plus 0x minus 9. If we were to factorize that, what multiplies to -9 and adds to 0? X minus 3, x plus 3, right? So we have 9 over x minus 3 times x plus 3. So I just factorize x squared minus 9. And then plus 3 over 2x plus 6. Now I could pull out a factor of 2, and we're left with x plus 3. Now notice in the denominators, we already have a common factor. So instead of cross-multiplying the denominators in full, we only need to do part of them. Right, so we'd get 9 times 2 plus 3 times x minus 3 all over, now here's the bit that's different, we'd have our common factor, we'd have our x minus 3, and we'd have our 2 times 2. So it's kind of like this step up here, but by doing that pre-step of finding a common factor first, our denominator isn't a cubic anymore. Now it's just a measly quadratic. So let's now expand, simplify this a bit. 18 plus 3x minus 9 all over 2 times x squared. Oh, actually, let's leave this in factorized form, just in case the factors cancel. So in the numerator, that's 3x plus 9. Denominator stays the same. In the numerator, I see a common factor of 3. And would you look at that? X plus 3's cancel. And we're left with 3 over 2 times x minus 3. So you'll notice same amount of working, except a few less numbers per line. And we didn't need to use our calculator to solve a cubic. Good job if you made it this far. See you next time.